Alright, so this is the very first video of Windows Privilege Escalation. So in this video we will start this from very basic and we will try to focus on the very main concepts of Windows security. Basically we need to find out what Windows security measures are and we need to also understand them so that we can know how to bypass them, right? So right here, as you can see, when we are doing pen testing, not in real scenario but when we are learning, right, we assume that we have got access to one of the device, right? So now we have access to this guy device, which is Dev right here. Now the problem is Dev is a regular user, and what I mean by that is Dev has like very low level privileges and we need admin rights because we want to install the persistent or get persistent so that it can, survive the reboots or when you turn off your device or turn on, so that we can stay connected to Dev, right? Another thing is we will also find out the password that is on this guy device to get higher level privileges, and we will also search for what software are installed and stuff. So by the help of this we can get higher level privileges, right? So as you can see right here, Dev is unprivileged and we need to escalate to administrator or either system so that we can have full control, right? So now let's just move to the first concept. First of all, we have is the security identifiers or SIDs. So how in the world does the window know that what a specific user can perform and what cannot perform, right? So basically it does not use any username or stuff, but it uses something we call SIDs or security identifier, which is a unique identifier assigned to every user as well as group, right? So when you create a new user or new group, the SID will be assigned automatically to them. So as I said earlier that Windows uses SID for all of these stuff when you are making changes in registry, file permission, and like system level activities. Now let's talk about the anatomy of or the structure of the security identifier. So this is how the security identifier looks like. So let's break down this and understand what this means. So the first one is we have the S. So this just literally means the SID, right? And this will be present in every security identifier for every user and for every group. And then we have this, which is what we call the R or revision level. This will be always set to 1, right? And then we have the identifier authority, which is this. So what this means is the identifier authority tells us who actually issued the security identifier to the user or to the group. Like in most cases, the most common value of the X will be like 0. If there is 0, it will mean null authority. If 1, it will mean this, and so on. And the most common one we have is this value, right? So it means that the SID is given by the local user or domain user. And then we have the domain identifier plus the RID. So let me show you what this looks like. So this is the domain identifier and this is the RID. So let's talk about what these stuff are. So as I said about that, this specific string is the domain identifier, right? This is a unique number or identifier to each machine or device or domain, right? And this right here, the RID means the this last number. From this number we can identify the specific users or group, right? And this one right here is very important to understand. So let's talk about this. So if you see somewhere that the RID is 500, so it will mean that this is the administrator user. Wherever we see the 500 RID, it will mean this. And if we see the 501, we will see that this is the built-in guest account. And the actual account we created on our device, it actually starts from 1000. So if you create the very first account on the machine, the RID of it will be 1000. And if you create a second user, its RID will be 1001, and so on. So for example, if you open PowerShell and type the whoami/user command, we will see the SID of the user we are logged into. It will show the SID of the user we are currently logged into. So in this case we are logged into Dev, and this is the SID of this guy, right? So we can see this is the second user that it was created on that machine. So right here, as you can see, this is the just we talk about that this mean the SID, and this thing right here is always set to 1, and this tell us who gave the the SID to that user, right? And this is the unique identifier of the machine that we are logged into, and this is this very second user. Remember I told you that if we create the very first user, the RID of that user will be 1000, and if we create the second user, it will be 1001, and so on, right? So let me just open the PowerShell and actually show you. right? So as you can see on the screen, I open the command prompt and let me just type who am I slash user command, and then we will see the SID of my user. So who am I slash user, right here as you can see, this is the username and this is the SID of this user. Now let's just talk about the access token. So let's assume you work in a very high security building or somewhere, right, where the security is very tight, and the company provided you a wristband that you wear, and it has all the data like your name and what you can access, which floor you can access, and which door you can open or which door you can't open with that wristband, right? So the access token right here is very similar to the wristband that the company gave us. So what actually is the access token? So when you actually log in into Windows, the system generates a kind of token which is what we call the access token. It contains all the information like user SID, or in other words who we are, and the group ID, that which groups we belong to, and also what privileges we have, and also the integrity level or trust level. We will discuss this part in a moment, and also session ID and these bunch of other detail, right? So let me actually show you what I mean. As you can see right here, this is the login screen. When you enter your username and password and then press enter, you will be logging into that specific user, and in that specific user the access token is generated that contains all of these information, right? So we do have actually two types of token. One is the primary and another is the impersonation. So let's talk about the primary token. So these tokens are something that when we start a process, like in this case like a notepad or any application, the token attached to each of the processes itself. So this primary token actually makes a copy of itself, and each of the processes we run, it attach the token to each of the process, right? So in this case, this guy start the notepad.exe, which is a process. So what this guy does before launching is it takes one of the copy from this guy and attach to itself, and after that when we are using the notepad, it using that token, and that token just tell the notepad that what specific action and what files that this user can edit or modify and delete and create, right? As I said above, you can see this example. This is the same thing. The notepad gets the copy of the token, and it attached to itself, and based on that token and the privileges of the user, we then access those files. And now we have the impersonation token. So these token basically attached to threads and allow a thread to act as a different user. So what I mean by that is, let's say this is one of process and this is running as a system, and this main process also runs sub processes, and the main point is that each of the sub processes can act as different user, like let's say this thread impersonating dev, and this thread to impersonating this user, right? And this thread right here act as like this is running by system. So let me open Google Chrome and actually show you what I mean by that. So as you can see right here, this is the Google Chrome I opened, and if we go to taskbar, let me open the taskbar and show you the sub processes of Google Chrome. Right here, as you can see, this is the Google Chrome, and as you can see, we have actually opened only one Google Chrome browser. Right here, this is the very main process of Google Chrome, and these are the sub processes. So why are actually these running? So let me tell you something. The Google Chrome actually store password and different stuff on our device, on our local device actually. So when we open the Google Chrome, it also launches these sub processes for let's say this one fetches the password, and this one gets another stuff from the database, and this one another, and this another, right? So let's say this sub process will act as different user, this will act as different user, and this one will have different permission, this one different, and this one different, right? So this is the main point. So basically the thing is, as we are logged into a low privileges user, right? And so let's say there is service running as system, and there is also some processes running for the help of that services to run. So what actually we can do is we can inject the code into that process that is running as system, and then we will have the token, and we'll use that token to gain more high level privileges. The next one we have is mandatory integrity control, or MIC, right? So imagine these are different bases. This one is the very top one, this is the second one, this is the third one, and this is the last one, right? So this guy can access and do everything. This right here can just access most things and can do most of the stuff, right? And this third one right here can do the normal stuff like basic stuff, right? And the last one we have is the restricted one. These guys can perform like very limited action, right? And the very last one we have is the unclassified. These guys can access almost nothing, as you can see right here. Now let's understand actually what we were discussing above. So this is the 5 integrity level. Basically, as I told you, we will discuss this, and now let's just talk about this. So in level 1 we have is the system, which is at the very top level, and the second one we have is the high, third one is medium, low, and untrusted, right? So let's say you have a system level permission. So what this means is you can perform system level action. And the second one we have is if you have access to this second level, you can perform administrative tasks or system modification, like you can perform high level action but not actually system level, right? And the third one we have is the medium levels. So if you have access to this level, you can perform basic level processes and like basic modification, not system level or high level. And right here, this level, as you can see, this is mainly used for the temporary internet files or installer temp file, right? So usually we use this level, the medium level, right? And then this level right here, they are extremely restricted. They can perform very few actions. So usually when we log into our device, we are at the medium level right here, as you can see. But when we need a bit more higher level, we then get access to the admin level or high level. And if you somehow access to this level, then you are good. The system is in your hand. You can perform any action and delete any file and install any file and modify any file. Everything you want you can do if you have the system level access, right? So for example, let's say if you are at this level, you can perform high level action and processes, right? And you create a file or anything. Let's say you write some text or anything in it. So what happens is that if this guy or a user with medium level permission wants to change or modify the file that you created and want to change, that user basically cannot do that action, right? This is what actually the main point of integrity level. If you want to modify that file, you should have high level privileges. So right here, this is the example of the integrity level. Let me just tell you what this means. So this is the another user tab admin. So this guy has admin level access or administrator or high level access, right? So when we type who am I command, the username and when we type this command in command prompt or PowerShell, this command will just tell us what users are in the administrator group. So right here, as you can see, this guy is in the administrator group. This guy can just simply perform high level action, right? Let's say if we want to check the integrity level of this user. So for checking this, we will type this who am I /group and this specific command, right? So when you check your integrity level, you get to see that your integrity level is medium. So basically what this means is that you cannot do the high level action. So right here, as I said, this user is the part of administrator group and he can perform high level action, right? So right here we are trying to save this string into this evil.dll, but when we press enter on this command, we will see that access is denied or we don't have permission to do this action, right? So the reason we are seeing this is our integrity is medium level and we cannot do the high level stuff. And to make this command successful, we need high level integrity. As you can see right here, system32 files are high integrity. We need the high level integrity so that this command will succeed. Remember, as I said you in the access token, that when you log into the user, as I show you this page, when you log into the screen, there are 2 tokens you get. One token is basically used for standard level activities and another token which is used for the admin level activities. So at the time you type this command and press enter, actually you are using the low level token, right? So to fix this problem, what actually we do is to open the command prompt or PowerShell as administrators. So when we run the PowerShell as administrator and run this command, it will just run successfully. So behind the scene, what actually happens is that when you open the PowerShell as administrator, it then uses the admin level token that we talked about. So right here, as you can see this command, what this is used for, this is the file. So let's say this DLL is inside the system32 and what we want to do is to check if we can modify this or we can delete this file, right? So what we do, we will copy this path, this specific path of the file like this, and then we will open the PowerShell, use this command and then specify the path. So after that, this command will just tell us based on the user we are currently logged into that if we can modify or delete this file or not, right? And after that, we will talk about the user account control or UAC. So next we will talk about the user account control or UAC. So you might know about this one. Let me just show you what this actually is. So right here in this image, as you can see, you might have seen this because when you install some software, it actually asks for this thing if you want to give it access or no. So what this actually means is that if you click on yes, you will give that software an admin level permission, and if you click on no, the application will not get the admin level access. So let's just discuss about this. So what actually UAC is. So right here, as you can see, before the UAC or this kind of pop-up in Windows XP or the earlier window, back in the days when you used to open an application, it will just directly open as admin. There were no any pop-up like this. In Windows XP or earlier window, when you wanted to open a file, you will click on that and it will just itself run as administrator. Now the problem with this is, let's say if there is a malicious .exe or malware, if that somehow run, they will just directly get the admin level access, right? So this is the main problem. And later Microsoft introduced the UAC or user account control in Windows Vista and in the coming Windows, right? So as we talk about is that when we come to the login screen where we enter our credential and then when we logged in and want to run any application, it just run with standard permission, not admin level or high level permission. So let's say if there is also malware, it will run but it will not have admin level access. It will have like limited access. So this is why they introduced the UAC. So now let's talk about how the user account control works. So basically when we logs into our device, the UAC create two different tokens. So the Windows create two different token. One is the filter admin token, another is full admin token. So this token right here can perform medium level operation and not like admin level, right? And the second token we have is that this guy, and this token right here can perform high level action, right? So as you can see right here, by default most of the processes use token number 1, which is this one. They don't have actually the admin right. But let's say there is an app that needs admin right, it will just pop up the UAC and it will ask the permission from us that if we want to give the permission to that specific application or no. So if we click on the yes, we will give that app the admin level permission, and if we click on no, the application will not get the permission, right? And if you want if the UAC is enabled or not, so you will open the PowerShell and run this registry query and find out if the UAC is enabled or not. If the user account control or UAC is enabled, you will see like this response, right? So this one right here just shows us that the UAC is enabled, and if there was 0, it will just mean that the UAC is disabled. Right here, as you can see, I have attached this screenshot. You can see that there is 1 and it means the UAC is enabled. So hopefully you like this video and I will see you in the next one. Till then, take care.